Hey everybody, it's Ripley again, back again. Let's do some more integration. So we got a whole bunch of skills. We got integration by substitution, we got integration by parts, we got integration by just plain old knowing antiderivatives of functions. But let's say you got something like this. Let's go that I have, let's say for example, that I have the integral from, I don't know, let's go from 0 to pi halves of cos squared x dx. Okay? Well, what do I do with this? I can't do a substitution because there's no part of the integrand that appears to be the derivative of cos. I got this squared thingy dingy that's going to give me fits. So what should I do? Well, when in doubt, turn back to your trigonometric identities. So I don't know what you remember from your trig identities, but cosine squared of x, or cos squared, can be written as, I'm just going to go the integral from 0 to pi halves again of 1 plus cosine of 2x divided by 2, the whole thing divided by 2 dx. Now, just as a little side note, let me change color. I'm writing in red because if you don't remember these, then I'm angry. Just remember, there's an easy way to do this. If I do sine squared x plus cos squared x equals 1, and cos squared x minus sine squared x equals the cosine of 2x. Hopefully you remember that. If I want to know what the cosine squared of x is, this is called a reduction in powers. If I add these two equations to one another, then do you agree I get 2 cos squared x equals 1 plus cos 2x, so cos squared x equals 1 plus cosine of 2x over 2. If I want sine squared x, then all I would do is subtract, and I get the same thing. So I would get sine squared of x equals 1 minus cosine of 2x, the whole thing divided by 2. Okay? So if I take that reasoning, once I have this guy right here, if I bring that sucker down here, then, well, what can I do? Well, that's a constant. Remember, we like to pull constants out in front because they make our lives easier. I get the integral from 0 to pi halves of 1 plus cosine of 2x dx. Now, I am going to assume that you are starting to get really familiar with integration by substitution. So if you need help with it, please come get me. But if you can't see that this integral turns into 1/2 times antiderivative of 1 is x, the antiderivative of cosine of 2x is the sine of 2x divided by 2. If you need proof of that, simply take the derivative of sine 2x over 2, and you'll end up with cosine of 2x. If you can't see that, do a u substitution. Let u equal 2x, du equals 2 dx, so du halves, which is where this 1/2 right here comes from, equals dx. And you can use the fact that the integral of a sum is the sum of the integrals, right? So I'm going to go from 0 to pi halves. I'm going to do this guy long-handed so we can see how it works. Right? So I'm going to end up with paren. I'm going to go pi halves minus sine of 2 times pi halves, this guy divided by 2, end paren minus, excuse me, 0 plus sine of 2 times 0 divided by 2. And let's see what happens here. This ends up equaling, I better come up here, hadn't I? So this ends up being 1/2 times, well, sine of 2 times pi halves, the 2's cancel, sine of pi is 0, well, that's cool. I end up with pi halves minus, that's supposed to be a minus, sorry, let me erase that real quick. I end up with pi halves minus 0 for the first term, minus 0 plus, see where that plus came from, right? Wait, why do I have, sorry you guys, that was supposed to be a plus. What the heck is wrong with me? You got to yell at me when I do stupid things like that. 0 plus, now again, sine of 2 times 0 is the same as the sine of 0, which is 0, right? And we end up with pi fourths. All right? Now, just for giggles, I'm going to go ahead and I'm going to open up my calculator, and let's do this guy. Let's have the calculator work it out for us. Sorry I didn't open this up in advance. We'll get this thing open real quick. Should have had that thing open, but it happens. Excuse me, this is where it yells at me. All right, let's see if we remember how to use our calculator to check our integrals. Remember, our calculator won't check our indefinite integrals for us, but it certainly will check our definite integrals for us. So let's check it out. Second, quit. Let's go to y equals. Remember, if you got plots turned on, this is actually kind of nice because I got all kinds of weirdness turned on here. I'm going to turn off my plot if I've been doing statistical analysis. Oops. If I've been doing statistical analysis, I go up and I hit enter and it turns the plot off, right? So just in case we want to look at the function. So let's say that I want to look at what cos squared x looks like from 0 to pi halves. I can just go prin. Remember, there's no way to write cos squared x, so I got to go cos x in prin, and then square it. And then I'm going to let my window go from 0 to, let's go second, pi divided by 2, right? And then I know it's going to be between 0 and 1, right? So I'm going to go from 0 to 1. Let's have a look-see at this thing. Hey, look at that. Doink. Right there. That's cool. Now second, quit. And I'll show you a couple ways to do this. Remember, I can go to math, and I can go, if I go down to FNINT, just like this. All right, this is always kind of cool. I'm going to go from 0, go up to second pi divided by 2. Now this is where you got to be a little bit careful here because we're going to have to insert extra parentheses. So I'm going to go prin, and I'm going to go cos x in prin, let's see, end prin, and then end prin again and square that. So it is a little bit cumbersome, I'm not going to lie to you. And then I'm going to get dx, so I tell it that all my variables match up. Remember how that works? And I get 0.7853. Hey, that sounds kind of familiar. Let's go second pi divided by 4. And voila. Isn't that cool? Now remember, I can also go to my graph, and I can go second calc, and I go down here to 7, so I hit 7. And once my lower limit, which is going to be 0, and hit enter. And once my upper limit, which is going to be second pi divided by 4. And watch this. This is always cool. Here we go. Whoops. You know what? I screwed up. I was supposed to go pi halves, wasn't I? So second calc, and we'll go 7 again. And lower limit is 0. Enter. And then I'm going to go upper limit, which is going to be second pi divided by 2, because it should fill the whole thing in, right? And let's see what we get. And there it is again. Isn't that cool? That's really cool. All right, so let me get back to some work here. Open this guy up. Now, what happens if it's not so straightforward, if it's not so cut and dry? Let's say, for example, that I want to take the integral, the indefinite integral of, say, sine cubed x dx. And well, now what am I going to do? I don't have some fancy little backdoor trigonometric identity that's going to get me there. So now I have to be a little more clever. Again, calculus is great because if you don't know your trig identities, if you don't know your trig well enough, it will punish you for it. It lets you know where your weaknesses are. Let's put it that way. Do you agree that this could be written as sine squared of x times sine of x dx? Now you may say, well, Ripley, what good does that do me? This looks horrific. Well, not really. Look close. Sine x. Sine x is the derivative of a function. What function is it a derivative of? Cos. Again, Ripley, there's no cos here. Oh, but there's a sine squared here. And according to my Pythagorean identities, can't I rewrite this as 1 minus cos squared x, right, times sine of x dx. Now, if I let u equal cos x, then du equals negative sine x dx. I don't want a negative sine x dx. I want a positive sine x dx, so I bring the negative across. And I get sine x dx just like I wanted. Isn't that awesome? So this guy ends up being, now go slow, 1 minus u squared. Oh, don't forget our negative. We'll throw that out front, right? Respect thy negative, times du. Now this guy is easy to do, but I do have to be a little bit careful. Negative, this is going to be u minus u cubed thirds, right? Plus c, because it's an indefinite integral. Let's not be too hasty. So this ends up being what? U cubed thirds minus u plus c. And I'm done, right? Wrong. The function started out as a function of x, and I have it as a function of u. So that implies that this guy equals what? Cos cubed x thirds minus cosine of x plus c.